In 7000 BC, the priests of ancient Jericho used glue and sorcery to fix the eyes into this skull. Since then, adhesives have really taken off, whether it be for use in the aircraft industry or for the assembly of wooden chairs. There is an adhesive for the purpose. The manufacture of GRP boat hulls relies extensively on the use of resins, whilst the mushrooming electronics industry is very dependent on adhesives for component assembly. The local council makes generous use of glues and pastes in education. There are even adhesives used for repairing the structural members of suspension bridges. Hot asphalt is used as a curing agent. In the motor industry, adhesives have been used during manufacture for many years. For instance, bonnet reinforcements have been bonded since the early 1960s. Today, manufacturers are moving more and more towards the use of adhesives in an increasing variety of applications. For example, they have become indispensable for fixing items of trim. There are double-sided tapes for use on weather shields and for fixing car badges. Aerosols for soft trim items, such as this anti-drum foam. The stronger brush-on rubber-based type for headlinings. A flash-off time of 10 minutes is required before joining the two surfaces. Toughened acrylics, used here to bond a mirror to a windscreen. The activator is used to clean the screen before application. The adhesive is squeezed onto the mirror bracket. After 5 minutes, the bracket can be fixed to the screen. An hour later, the mirror can be fitted. There are also two-pack materials which can be used to fit bumper brackets. Sensible health and safety precautions should be taken when using adhesives, and it's important always to work in a well-ventilated area to avoid any build-up of harmful vapors. Manufacturers are also using adhesives to fix some cosmetic panels. The rear wheel arch on this Citroën AX is bonded, as is the door skin. The drive towards greater economy and ease of manufacture, together with improvements being made to adhesive materials, might well lead to these expensive welding robots being replaced in favor of bonding on all cosmetic panels. This would allow the greater use of coated steels and aluminium alloys. In line with its policy of keeping abreast of current practice in the motor industry and developing new repair techniques, the Motor Insurance Repair Research Centre has been carrying out research into the use of adhesives in the repair situation. This Rover 200 body shell is an example of some of Thatcham's early research. All the cosmetic panels have been replaced using an adhesive in place of the manufacturer's welds. Part panels on the front wing and the sill were also fitted. Several different adhesives were tested during this research to assess which would be most suitable for use on future projects. A destruction test at double normal impact speed was carried out on another Rover 200. The inner and outer wheel arches, as well as the quarter panels, have all been bonded. The doors and mechanical items have been left off, so that the whole force of the impact will be transmitted directly to the bonded joints. On examination, it was found that although delamination had occurred, the impact had caused no significantly greater damage to the vehicle than if the joints had been resistance welded. Weld bonding of the joints on both these Rover 200s had been found to be preferable to just using an adhesive. Adding a limited number of spot welds to a bonded joint greatly increases resistance to separation by peeling. This cutaway panel is an example of how joints on box sections are strengthened by the use of a backing plate, which is spot welded and riveted into position. Thatcham has also been cooperating with the Rover Group and Press Steel in researching the weld bonding of panels on the Rover 800. The rear quarter panel on this car has already been removed, and the surfaces prepared in the same way as for a welded panel. Backing plates have been cut from the damaged panel for each of the 3 box section joints on the rear screen pillar and C-post, and on the sill panel. A zinc-rich weld-through primer is applied to the backing plates. White metal areas around the box section joints have also been treated to fight corrosion. Once clamped into position, spot welding can be carried out. A red oxide anti-rust primer is then applied to the internal face of the joint. The backing plates have also been fitted to the C-post and sill panel, and similarly treated against corrosion. The new quarter panel is offered up and clamped in position. Door and boot lid gaps are checked in the usual way. Using a 4mm bit, holes are drilled through the new panel and into the backing plates. The panel is removed and the holes all countersunk. To eliminate any traces of moisture, a hot air gun is used around the edges where the adhesive bead will be laid. The Acamet C primer is now being mixed. 10% solutions in water of both the wetting agent and the Acamet have already been made up separately. These are now mixed, 3 milliliters of wetting agent to 100 milliliters of Acamet. The primer should be generously brushed on all over the joint areas. Thatcham has found that this primer is very important, as it greatly improves the durability and performance of bonded joints. A hot air gun is again used to dry the primer and remove any further moisture. The procedure of countersinking the drilled holes, drying with hot air, priming and drying again, has been repeated on the new panel. It's always important to choose the right adhesive for the job. A thixotropic material is required here, which will not run out of the seam. Single-component adhesives require very high curing temperatures, which can usually only be achieved in manufacture. Two-pack materials like this epoxy cure by chemical reaction and are thus more suitable for use in a repair situation. The adhesive is mixed automatically in the correct proportions as it comes through the nozzle. The finished adhesive layer, known as the glue line, should be approximately 500 microns thick. Thatcham has experimented with glass beads mixed into the adhesive to help maintain the correct glue line when clamping the panel to the car. There are 3 main advantages to using bonded panels. In many cases, time savings can be achieved because extensive removal of interior trim items is not required. Additionally, any heat distortion which might be caused by MIG seam welding is avoided. Lastly, the risk of poor quality welds arising from difficulty in joining different types or gauges of steel is eliminated. It may be difficult to use the gun on certain areas of the vehicle, such as round the wheel arch. In these cases, the adhesive is pumped direct onto the new panel. The panel can now be offered up for the final time and clamped in position. As was just mentioned, care must be taken not to over-clamp and thus squeeze too much adhesive out of the joint. The rivets are prepared and fitted through the pre-drilled holes in the panel and into the backing plates behind the 3 box section joints. Thatcham has found threaded aircraft-style rivets give better control over joint tension than conventional pop rivets. Spot welds are used at intervals of approximately 100 millimeters, but especially in critical stress areas. No weld-through primer is required here, as the adhesive fulfills the same purpose, preventing corrosion. Finally, any excess adhesive is removed. Curing is best carried out at a metal temperature of 40 degrees centigrade for 1 hour. Most 2-part epoxy resin structural adhesives will not reach full tensile strength if heat isn't used. Additionally, adhesives cured without heat may reactivate when subjected to paint oven temperatures. For the time being, however, adhesives should only be used during repair where recommended by the manufacturer. The wheel arch on this Citroën AX has been damaged by the impact. Because it was bonded in manufacture, an adhesive can and will be used in the repair. The bulk of the panel was cut away so that a check could be made on the condition of the bonded joint after impact. Investigations revealed that the bonding material was not a true adhesive, but an expanding foam PVC, which required a curing temperature of about 120 degrees centigrade to activate it. Such a temperature would cause damage to a finished vehicle. The car was repaired, and a decision taken to replace the original material with a 2-component polyurethane-based adhesive sealant. This was chosen particularly because it cures by chemical reaction and not by moisture, as in the case of single-part polyurethanes. The risk of corrosion is thus significantly reduced. A special nozzle had to be made up for the gun to overcome the difficulty of access underneath the wheel arch. It was also necessary to put a bead of the bonding material inside the vehicle to complete the sealing process. The door skin on the AX is also bonded and is shown here being replaced. Any spot welds are removed with a cobalt spot weld cutter. The quarter light reinforcement rail is cut through with an air saw. The door skin edges are ground away and the remnant removed. Using a hammer and chisel, the bulk of the door skin is then easily detached. The spot welds holding the remnant of the quarter light reinforcement rail are revealed and removed with a cobalt cutter. The edges are cleaned off to bare metal using a sander and wire brush. The new skin is then prepared. Acamet primer is to be applied, and so the manufacturer's primer is removed. Areas to be spot welded, such as the quarter light reinforcement rail, are cleaned off with a wire brush and treated with weld-through primer. A hot air gun is used to remove moisture, and the Acamet primer is applied and dried off. the same procedure as was carried out on the Rover 800. The door has also been treated with Acamet. Adhesive is applied all round the door edge and brushed well out. Thatcham has found that to leave the bead without brushing can cause serious difficulties later. When using the hammer and dolly, the adhesive forms into uneven patches under the skin edge, and it can take a long time to get a smooth finish. The adhesive is also applied along the inner edge and brushed out. In this particular case, traditional crimping methods are used. Any necessary resistance spot welding is then undertaken. After curing under heat, the edge is cleaned up with a sander and wire brush. The front of the door is finished with a random orbit sander. Full information on the AX door skin replacement is given in the Stage 1 research work published in Volume 4 of the Thatcham Methods Manuals. To compare bonding against welding, Thatcham conducted tests on a tensometer. At the top is the resistance weld, and at the bottom the bonded joint. The test specimens were made up with 1mm gauge steel. Examination of the graphs produced proves that bonding can be just as effective as spot welding. The spot weld failed at 6.5 kilonewtons and pulled a 5mm nugget. Chemical pre-treatment enhanced the strength of the bonded joint by 0.3 kilonewtons. The real advantage of the Acamet, increased durability, is only realized in service. A willfully delinquent operator quickly sees copious filler as an easy way of hiding an incompetent repair job. In reality, the minimum amount of filler should be used, consistent with the restoration of original panel contours. Body solder or lead has been in use for many years. After the tinning compound has been applied, it is heated with a propane torch. Any residues are removed with a suitable cloth. The solder is then applied to the joint. The use of even this limited amount of heat can cause distortion to the panel, especially in these days of even thinner materials. Stringent regard for health and safety precautions is essential whenever using lead. Thatcham has published a newsletter giving details of the right lead to use during panel repairs and of the range of materials available for dispersing the corrosive flux residues. The area is shaped and dressed using a body file. Finishing was carried out with a random orbit sander fitted with 80 grit paper and coupled to a dust extractor. The bonded C-post and sill panel joints on the Rover 800 are to be filled using a polyester material. Some polyester fillers are known to be hygroscopic, that is to say they have a high moisture pickup factor in their uncured state, and are thus susceptible to moisture transfer to the underlying bare metal. The importance of thorough and careful rubbing down to a fully feathered edge cannot be overemphasized as the basis for a first-class paint job. Haste at this point can not only spoil the finished result, but cost